Hey, so welcome back to our solving solving part for the sixth and seventh lesson in our geometry subject. We have the surface area, volume of 3D figures. Okay, so we have this problem. If a cube is cut thrice parallel to any of its faces, what is the percent increase in the surface area as a result? So to better solve this problem, it would benefit you guys if we were to illustrate this problem, if we try to draw it. So first, let's try to draw a cube. Okay, so for this problem, we have a cube. Okay, and according to this problem, this cube would be sliced. This cube would be sliced into thrice parallel to any. The cube is cut thrice parallel to any of its faces. So that would mean we would create three new cubes for this problem. Okay, so how would you create three new cubes? So this is gonna be the first division. Let's try to use a different color. This is gonna be our first division, and that would give you two cuboids. Okay, that would initially give you two cuboids. Okay, okay, so this is the first cuboid plus the second cuboid. Okay, okay. Now for the second cut, in order to create the three cubes that we desire, the three additional cubes that we desire, we have to cut it again. This time at the center, and now we will form the three additional cubes that we have, resulting into four cubes. So we have here one here. We have here one cube. This is the second one. If we add these two, so it will give you the cuboid at the top, and then we have another cube here. There you go. So you have another cube here. Okay, and then lastly the second cube here at the bottom. There you go. Okay, so if we add all of these four cubes, they're gonna give us the same exact big cube. Now, since this was sliced, so the volume is still the same, right? Since we didn't add anything to the figure, so the volume would just be constant. The volume of the first cube of your initial cube would be the same as the sum. Okay, same as the sum of the four smaller cubes, the volume of the four smaller cubes that you have. Okay, so these are your smaller cubes, and this is your initial cube, V sub IC. Okay, so they're all just going to be the same, the volume. But the volume is not the one that we're looking for. We're looking for the surface area. So what is the percent increase in the surface area as a result? Now think of this problem as a gift wrapping problem. Let's say, for example, you have a gift in the shape of a cube, and then you have to divide it into four different parts. So that would imply you using a gift wrapper, much more gift wrappers, because you just divided one big gift into four smaller gifts. So that would mean you would need to use more gift wrappers. Now the question is, how much more gift wrappers are you gonna use after dividing this cube into four congruent parts? The volume is still the same, the volume is still the same, but the amount of gift wrappers that you will use would be quite different. So what's gonna be the percent increase on that? Okay, we all know that a cube has six faces, six congruent faces, and all of them are squares. So if they have six faces, and all of these four cubes that we have here also have six faces, so we can multiply that by a factor of 100% in order to find the percent increase to get the additional amount of surface area that we will need for this given problem. And to solve for this problem, so that's going to give us 6 divided by 6, which is 1. And what's 1 times 100%? So that should give us 100%. So that would mean our answer is letter C. You would need 100% increase in terms of surface area, in order to wrap these four gifts, these four smaller gifts, or these four smaller cubes that we created from the larger cube. That's kind of like saying, let's say for example, you bought a gift wrapper that's like 5 meters by 5 meters. That means you're gonna have to buy another gift wrapper that's 5 meters by 5 meters, because it says here that's 100% increase. Okay, so that would mean you'll need those two big gift wrappers to wrap the four smaller gift pieces that we've created for this problem. And that's how we solve it. So the answer for this problem is letter C.